my lawyer got involved with it, just for my own, protecting my interests with all this stuff. And so that's how
Additional energy.
what we understand the physicists put together is a circular cylinder of unknown height. When the when the fields are interacting, something's formed there, a third derivative. It seems to make things weightless, and they either just simply are weightless or they float. Or sometimes they have a propulsion to them, where they actually go up so fast they hit the ceiling. Other times these things will move sideways. So that's indication of some type of force at play there.
You don't use any energy, any frequency to that, or you use?
I use well, everything happens at a distance from the equipment itself. And it's radio frequencies, multiple radio frequencies that are specialty kinds of frequencies, like I'll maybe use a sawtooth continuous wave pulsed, a band of frequencies, and then I'll use electrostatics. Somehow there's a very strong relationship between these two. And pulsating direct current fields. The only other thing I use is an alpha-beta source, which is tritium. It's about 200 millicuries. And that is located within the electrostatic field.
Do you have any written referates or news in newspaper, in scientist paper, or no? Did you write something about that? And
no, as you know, I'm not a scientist, but has been going on for the last number of years. Other scientists have been writing up books and papers on it, on what I'm doing.
So
I'm not a writer. I don't.
I see.
No, I'm more of an engineer kind of fellow. Can you describe it?
explorer, artist.
Yeah, that's what I am more. I'm not a scientist. I won't go into like.
Yeah. You know, I am an engineer from Poland. You know, and when Tom said me about you, I saw you a few years ago in Abbotsford in TV. You know, because I am living in Abbotsford.
Okay.
And you know, I saw you. It was some program with you. Do you know about or no?
I have no idea.
A few years ago, you know, I saw, and when Tom told me about that, you know, I said, oh, I know this guy, you know, from the news. They show, you know, when you were collecting big transformers, you know, you said that you are buying transformers in different places, you know. And I knew, but now, you know, I wonder, my questions was, you know, it's only for me, about this
levitation.
This levitation, you know. I was wondering, I am skeptic, you know, to everything.
Good. That's
like an engineer, you know. For me, it should be, you know.
I am too.
Yeah, and you know, I was wondering, do you use additional energy to pick it up, these things, or no?
No, it's
No.
no. The energy is when the energy is constant. So from the house mains here. So when there's say the frequencies match up, then something will happen, but there's no increase in primary energy.
Okay, but you have to generate some frequency.
Oh, many different frequencies. Yes.
Yeah, you have to generate.
Yes.
Yeah. Okay. Because yesterday Tom asked me about, you know, the energy meter in electrical at home, you know, the meter. And I explained him how it is working, you know, and we were thinking that maybe it's the same idea in your...
So like the Hall effect.
Like you know, the...
Two magnetic fields.
You know, if you have frequency, you have, you know, rotated currents.
Yeah.
How do you call it? Oh.
Lorentz forces on that.
Yeah.
There's ways you can levitate. Conventional levitation, like magnet lev.
Yeah.
You can
Magnetic.
You You can use a linear transformer
Yeah.
or repulsion coil, and you
Yeah,
get a
yeah.
dish of aluminium going up and it'll fall down.
Yeah.
It's direct.
And it is same idea or no? What you are
No.
doing? No.
No, very different. The other one is, of course, is direct connection, which is a high voltage wire connected to a plate. That was T. Townsend Brown's work, and I replicated some of his work, and I found it quite interesting. That's where you have high voltage coming onto a capacitance plate, and the thing will start spinning around and moving around on its own, which is interesting. Then there's the lifter tech, where you have the high voltage on a very light frame with metal on it, and one wire running to it with high voltage going to that, and it'll lift right up. And I think that's more of, to be honest, I think that's more of an ion wind force.
Yeah.
Which is very interesting unto itself, though.
Yeah.
If you could have that self-contained, you'd have a unique device, ion drive or ion power. And in this case, it's a remote situation using RF and electrostatics. Now, electrostatics unto themselves will lift small things up and throw them around.
Yeah.
Or you can actually have them float around. What they used to do in experiments is have a V-shaped piece of metal, let's say aluminium, and it'll float around the outside of a round ball, which is electrostatically charged. It's quite intriguing what electrostatics can do.
Yeah, it was in the past years, you know, it was like a Leyde's bottle. Did you listen about this?
The Leyden jar?
Bottle, like a bottle, you know, and you had two small, like we said, leaves, aluminium leaves, you know, and if you put high voltage to that, you know, the leaves was.
Oh, electroscope.
Yeah, something like that. Yeah.
Yeah.
Electroscope was, you know, to make this voltage.
Yes, I know that.
Yeah.
The old first one was Ben Franklin. He made a round ball of glass, post on it. You could turn this ball, and he had horsehair collecting the static from it. And that was
Is your levitation experiment relating in any way to acoustic levitation, for example? Because they do experiments with, you know, sound frequencies to move some small objects, hang them in air. At least that's what I've seen on YouTube.
Well, I've done that too.
Have you?
And I've done it with barium titanate, heavy material. And
How heavy?
About 7 pounds.
Oh, and it was up?
It was maybe only millimeters up, and it would move around by itself, but affect the objects around it, and then move them around too. That I actually demonstrated for Lightworks Audio and Video, the Race to Zero Point. And it was actually a fun experiment to do because you could just turn it on and you could do all kinds of funny things with it. And if you tried to grab that barium cylinder, you couldn't. It's like a force field around it. It's slippery.
Wow.
Yeah.
Wow.
So unfortunately, one of my girlfriends really loved doing it too. And we used a Crown amplifier. It was, I believe, 600 series. Roughly 2,000 watts out, and then it would go 0 to 110 volts. So if you talked into a microphone, you could light up a light bulb and you could see the modulated form of the light bulb. So this thing was tied into that amplifier. Unfortunately, she left it on too long and she actually burned out the transistors in it. So I said, okay, you know, it's a bit of a shame because I could be portable and take a 200-pound Crown amp, that's how much it weighed with handles on it, and then the barium, and go on a lecture tour and set it up and show people how you could do acoustic levitation.
So frequency influenced anti-gravity has any relation with acoustic levitation, for example, because those are also waves, you know, attacking the object.
That's right. A good point. It's kind of like sound waves doing similar things as radio waves.
So there is some relation probably there.
I would think so. The closest relation I can think of, if when that was going, it affected objects around it. You could see them moving around, which was away from the actual equipment.
So seems like the object that is being lifted resonates on its own somehow.
Well,
It picks up the vibrations from the source, or
I use feedback. Because barium titanate is used in sonar. And so then sonar, like these machines here and others, they have a sonar head, and they send out the sonar signal. So this stuff was available from fair radio sales in Ohio, and it had the capabilities of self-charging itself. It's almost a free energy thing, and actually, when word got out about it, fair radio was sold out of this stuff, and people are still begging for it, and nobody wants to sell it. So when I got it, I know that's being acoustic in nature. I was playing with it, and it gave off a massive amount of sparks. I almost electrocuted myself in one experiment. Then I tried the experiment where I had the amplifier going right into it, and then with a microphone, it set up a feedback loop, and that caused it to resonate. Fascinating experiment.
wow, it's just mind-boggling.
It's a very squealy sounding kind of thing, and that attracted the squirrels coming in here through the window. So I showed some people the experiment, and the squirrels came in too. I guess the high sounds seem to attract animals, but they came in. My friend from Japan is laughing, actually.
So, is there any like a recipe to do your experiment at home to replicate it? You know, the anti-gravity, or you just don't really share?
Oh, I share as much as I can. I shared with this Army intelligence. I share with everybody this stuff. It's I do not wish I don't want Nobel prizes or patents or any of that. As I told my producer, I said this stuff is if somebody can understand it and replicate it, good. So one scientist has Ken Shoulders in the United States has replicated aspects of it, and a few others are replicating and playing with it quite a bit. But for really getting involved in this, I would recommend starting out with electrostatic generators and Tesla coils.
Oh,
Unusual effects do happen with them.
I have a device called electrostatic remover. It's like it's got a spinning wing, you know, for air ventilation.
If you want to make more movie,
Yeah, I'll stop for a moment.
Oh, you
maybe just to preserve my back.
On wind, let's say in an area that's dry, then you have a big spinning disc, and they would show you how to make one of these little motors. And if, let's say you're in a room and you have a small Van de Graaff generator, and one of these motors, it'll actually start spinning on its own.
okay, but it is air is going to rotate, yeah? Air.
The Earth is always rotating, yeah.
Air, yeah?
That's why we get some liftoffs here that are on an angle.
Yeah, I see.
Some of them go on an angle, like because of the liftoff of the Earth, or the rotation of Earth.
It's bending.
But luckily it does that, because it was just simply stalled, and we'd have something like a missile at 212 feet per, or 212 miles per second blow through the.
This rotation, how big rotation in this air is?
Well, speaking of the main rotation of our solar system on the edge of the galaxy, because there's time relationships to every one. Now the Earth rotation, about 18 miles a second.
Yeah, but here in for example in your laboratory, if you take this 50,000 volts. You have did you feel this effect, this rotation, rotated air, or no?
There's some, no, I don't feel anything. There's some side derivative effects.
Because you said about motors, then I understand that it is enough, you know, to put two plates, yeah, big potential, and should be air, should work.
Well,
around,
no,
yeah?
actually, with electrostatics, you can have just one by itself. Let's say 5 feet away, just a plate with specially designed little points on it, sitting on a pin, and that will start spinning on its own if you turn on the electrostatic generator.
Oh, these electrodes are rotated, or air?
Oh, the the motor will.
Oh, I
They
see.
call them electrostatic motors, and they'll start rotating because the ions collect to them and they form an ion wind.
Uh-huh.
So the ion wind starts spinning these around a bit.
I think NASA has this ionic engine.
Oh, they actually, I saw one in Nevada State University.
Uh-huh.
I was visiting a scientist friend of mine, Dr. Rauscher.
Uh-huh.
She took me down in the basement, and it's this massive machine. It was so well made, heavy. It must weigh tons. It was an ion cannon.
Uh-huh.
She says, "I'll show you how that works someday," she said. I never got to see it, but I'd love to see that.
You've gone to JPL a lot of times? Or...
That's folks there that
Uh-huh.
we gave a talk in Los Angeles in 1997. And they came to the talk,
Uh-huh.
and they were showing me pictures on how they built the Mars lander.
Uh-huh.
Very simple, actually. They had to
Yeah.
they had to actually go to the surplus and get radiation hard chips. So no, I've JPL people, Kennedy Space Center people want to actually hire me for a while, but the director, they had actually had a meeting, and their director said, "Well, we want to stay on with our main project."
Yeah.
So
Yeah, they don't really understand
no.
creative people.
Well, I was willing to entertain the idea, and the last year was pretty bad because the U.S. they showed the videos in the U.S. Pentagon, and they had about 400 people watching them, and they got a standing ovation and say, "Get John involved with us here," kind of thing. And then they had Timmy Ventura from American Anti-Gravity coming around knocking on my door and saying, "John, you know, we got to get demonstrations. We can get funding and all that." And I was with a girlfriend at the time. I said, "Tim, I think the best way for me to go is into the media and present it as unique entertainment for everybody else, because going into that situation again, I don't like...
Getting involved in...
I don't mind it. I mean, it's just that you can't really do anything.
Yeah.
You can't go
Your
being
own
a
way.
show-off like I am a show-off. But you can't put it in the news media, and that's why I didn't sign a lot of contracts. You can't talk about it. With Canadian government, I was presented a contract, and I didn't sign it. I still got the contract, never signed it. So it's just too restrictive, and I don't like 9 to 5, where the creative energy has to be forced. Then
Yeah, it's better to be independent from all the
I like independence, and
more...
if
As long as you have sources, you know, to
yeah,
do your work,
it's
probably.
strange how my life is that the sources do not seem to be in the entertainment industry, like Discovery. People come and go from here, and I get challenges from them. They say, "Build the Ark of the Covenant,"
Oh yeah, I heard about it.
and
Yeah.
I did. They phoned me here, and Bruce Burgess said, "John, I got a project for you. I worked for him before." And he says, "Can you build an Ark of the Covenant? Can you do this kind of stuff?" I said, "Yeah, let me at it." So we worked
Wow.
out a budget. We did studying on it, and we built it in New West here and tested it at P&J Metals in Richmond, and it worked.
Wow, how did it work? I mean, what was the secret of it?
I helped it a little bit. Basic electrostatics again.
Okay,
I gave it a little kick charge
okay.
because it was damp, cold. It was this time of year. So it actually snowed out, and I was with Corinne, and we did the testing. After it's all finished with acacia wood, and it was laid inside and outside with materials, it did work. It's beyond what I ever thought it would happen. Because the producers were phoning me saying, "John, good luck, because, you know, if it doesn't work, we got problems." And I said, "Okay, I'm kind of nervous about this because, you know, what if it doesn't work? You know?" It's like, kind of thing. So we did the test. Rudy was our cameraman, and they were waiting for the results from Rudy. So it worked fantastic. Started very slow, and then this great spark jumped between the two cherubs. They got stronger and stronger, and the sparks started running down the sides of them into the wood, and the wood started to catch fire. And then this huge fire started. So Rudy said, "Well," I said, "what do you want to do?" Rudy's running around just filming everything. He said, "Not yet." And then the owner of P&J Metals, he's getting nervous. He's like, "This is my metal shop. Like, guys, I don't want it destroyed." Nigel, his name is, and Paul and John there. So Rudy eventually said, "Corinne, get the fire extinguisher." So she got the fire extinguisher, and then she says, "I don't know how to use it." But Rudy's pull a pin, and point. It was out, and there was a huge mess after. But so Rudy reported in by cell phone to Bruce and to Renee Barnett, the producers from Blue Book, and we had a big rap party that night. So it hasn't aired yet on Discovery. One of the shows I did about almost a year ago. Last year was History Channel. Earth's Black Holes, and that's airing now. And we had the stuff running in there and interviews in here. So yeah, the Ark of the Covenant, that was a challenge. Our main challenge is going to be the Philadelphia experiment. I'll be working with Dr. Ron Mililoni of BAE Systems. He's an engineer in that. And we have the ideas that we can pull it off.
And did you have any success in this field, like Philadelphia?
Minor success last summer.
Minor.
And I had a small Navy ship, foot long, that I tortured. I used high voltage and electrostatic energy on it, and I actually got some strange results. Sparks started to come off of it.
And it was any changes with the vision of that?
I took a lot of photographs and video of it.
And it was?
It didn't vanish. Like it phased in and out, and the camera would shut itself off. But one of my webmasters got the footage and put it on the website. Now it's kind of interesting because just the other day I was doing some experiments, and I took a quick, I always had the video camera pointed in that direction to catch anything if anything happens. Sometimes it doesn't, sometimes it does, but the water started really levitating up out of the container where the ship is.
Wow.
So what I did was take I have a small digital camera, so I started taking pictures of it. And I could see stop motion of the water drop. I thought that really fascinating. So I put it on the blogger, my crazy blog thing, and the photographs, which got a lot of people's attention. So the main thing down in Hollywoodland will be with Ron and myself. We'll probably use a 4-foot model, and either we'll blow it up or it'll vanish, because reported in some of these effects is some of these test samples have vanished, disappeared from view from Super 8mm film. Under analysis, they analyzed it frame by frame by frame. They saw some samples disappear.
And they never returned to the place?
I got the samples.
Because I've seen
The barrels of them up here.
under your levitation experiment, certain objects would also disappear. I've read the metals would become different in...
Very much so. I have, Los Alamos has a lot of those samples. George Hathaway has them, and I got a lot of them here, right here.
Can we look at them?
You
maybe?
sure can.
All right.
Not a problem.
Yeah, it's possible.
Oh yeah, I got.
It was like a habit, you know, to make transceiver by own, you know, by my hand. And while I was young guy, it was tubes, no transistors, nothing like that, you know, and we were experimenting, you know. We took from the radio
I love
tubes, you know.
Vacuum tubes.
Tubes, yeah, tubes, you know, and we made with my brother transceiver, you know. It was funny because on different illegal frequencies.
I love doing that too.
And you know, it was communist country,
Yeah.
and you could go to the jail, you know, because it was, you know, iron curtain.
Iron
Yeah.
curtain, I remember.
Okay, we can go, tak? Yeah. Which place?
The bigger barrel in the other room. Start pulling these out.
Oh, what's that?
These are some of the samples. I got lots of them. A lot of them I gave away to people, friends, but
Oh, it is funny. You see?
Yeah. disruption, right?
Yeah. Okay.
It's an unusual type of... They've been analyzed a lot by Hathaway's group. Not these ones as yet, but he's got lots of them, as much as I do, I believe. This is stainless steel. Some of these are on video.
So, in basic words, can you describe what actually happens in that field of frequency when you place those objects?
Well, this is some of the effects we get is metal turning into jelly.
Uh-huh.
This is not... It looked like there was almost a separation in this piece here, but not. It didn't quite make it. This is stainless steel. It's very heavy and it's used in high-grade engineering and stuff.
And it happened during the levitation? No.
No, this is something that happens. Something here you can hold on. It's heavy. Then sometimes they'll start to try and... I think this is the same material. It just turns to powder at the end.
Wow.
And that's all was solid at one time. And it's turned into all this dust, and it tried to bend. And you see there's a lot of distortion and
Yeah.
on that. Now I do have a lot of samples that have broken in half.
And they bound with different materials as well, right? Not so much.
I don't know. It's very hard to tell with this thing. It's I'll just put more in here. This is more stainless. That one did break in. I never noticed that in the dark stuff, but this one did break in half. And I think I got the other piece.
Okay, and what experiment was which broke it?
That would be the 1980s.
But okay, what kind of experiment? What did you do with that?
We put in the target area metal samples to see if they levitate, and instead some of them...
Oh, it means that it is during levitation. It happened.
No.
These damages, no?
It's during the experiment, but they don't levitate, they just blow apart.
The attempt was to levitate them. And
Oh, I see. Before.
Yeah, they're very odd. We've had only minor effects here. This is an odd piece here. It's like the material. It's got a date stamp on it, October '88. This is aluminium again, and it looks like this area was exploded out.
from solid object. Wow.
Let me just dig into this barrel again. I think that's this is I have the other piece probably in the other drum of this one. Another smaller piece of stainless steel. I always do that there. It blew up. And I think that's it for this drum.
Okay.
I have a bigger drum full of more impressive samples than this. So that drum is in, used to be the kitchen in there. It's not anymore. Which means I have to go this way and open up that drum.
Can we see levitation or no?
Well, we can ask him.
Because
Yeah.
she saw us.
It's good and airtight too. Yeah, let's see. This is from this actually is a shrunken peanut butter. No, he's working, and he has presented my work to MIT.
It was done in your house here.
Not here, not right here, but in the other laboratory. Are you filming it, Tom?
Yes, I'm filming it.
You can see it okay from that distance?
It's kind of dark, but
Okay.
I can see it.
They're another piece of aluminum. No, I'm gonna move.
Keep it for a second.
Okay. Na razie nic nie widzę. Tak, chyba tak. Yeah. So is everything okay, or
Everything's fine.
we didn't see much, but maybe the ship was
What
supposed to
should
move.
be going up? The ship?
Oh no, actually the water.
The water? Oh yeah, it was. I've seen some wrinkles on the water before. So that was it, right?
Was there any stuff moving around?
No, just the water actually did the
Big ballast or
the big plastic kind of was, you know, vibrating.
Oh, which plastic?
The container, where the ship is in.
Oh, okay, good. Yeah. And at the back, I saw in the video, the can took off.
Oh wow!
I don't know if you got that one or not.
Probably didn't get that one.
Oh, I did. That's why I got both a dedicated camera. It's gone there. I don't. Unless it's vanished into another dimension.
Which one?
I was.
Oh, it's gone.
Yeah. Don't see it. I saw it on the monitor. It just shot off and landed.
Yeah, okay.
That's on video. My video, anyway.
Okay. Well.
Okay. Did that big round thing that's hanging by a string there move? Or?
Yeah, it was.
Oh, cool.
It was moving around.
Oh, good.
I mean, the whole thing was moving.
Yeah.
The shells upstairs.
Yeah, that was one of our main things. It was grabbed onto that equipment up there and shook it. But then it seemed to be the target area moved towards a small boat and then towards the very back.
Okay. Oh, I saw the aluminum foil along with the big shelves moving around. That's for sure.
This is good. But you didn't.
That was
You didn't.
that was it. I thought I was.
Sometimes. But this is what I do by tuning here. So I operate all through here. Phase shifting through this system here.
You adjust the frequency here.
That's what I do here. Also up here. This is a high frequency. It's what they call a radar jamming unit. They come in handy for my research in this area. I have monitors. I have other RF generators in there. But the red light, of course, is for fun.
Yeah.
And then I fine tune here and I fine tune down here. Along with my RF system here, and then I have a spectrum analyzer, and I use parts of this for RF generation in the back, for the back cables. Also it's acts as a monitor. And down here, like a small control panel, and an RF unit down here, and then phase shifters, shifting the, twisting, working the electromagnetic lines of force. Somebody is getting upstairs here, going to be a little hairy. We've had tenants above us that moved out of here, were taken out by the police because stuff started to happen upstairs.
Really?
Yeah.
Wow.
Not good. They went to the news media too. So I do a lot of my tuning here and above me here. A little hard to move around, but I do. And then also in the back there, I do the same. Once this is set, I'll go and check how the back here is. Everything's working fine. And right above you is an RF generation system. Right? Yeah. Here we go. Thanks. Oops. That's where a lot of my RF signals go in. It branches out. So some of the RF is generated in here, and most of it's in the back. Along with the high voltage electrostatic.
Okay, Tom.
Okay.
Thanks. Yeah.
Yeah,
We are sorry for visiting you and take your time.
Why? I enjoy it when people come around and
Good. We're afraid about towing because you have here 2 hours no more.
the car we parked in the
So
2 hour
2
zone.
hours, you know.
Yeah.
you don't have to
Somebody
worry.
can tow us.
I think you're safe there, but I'll show you what you guys probably missed on your video. There's
Okay.
that little TV there.
Okay.
We climb it right there.
Okay, we should go there or no?
Oh no, I can do this.
Okay. Oh,
There's the camera. So what I do is I turn stuff, turn that on, and ouch, play it back. Stop. Okay. I'm not sure if that's doing it right. Okay, play video. Let me see if I... Okay, let's go back a bit.
Tak późno jest? Czwarty?
nie. Trzecia jest.
Now it's moving. Oh, there we go. So there's the can in the back. Go ahead a little bit. Oh, okay, I almost got it.
Yeah, it was.
Now play. Well, that's what you guys missed.
Okay, which one is it?
Right here.
You mean this hanging?
No, there's some can.
Can, now see how it's slowly, that's moving. See how it seems to twist that whole upper section around. And prior to,
Oh yeah, the aluminum foil went
and then the
up. Yes.
can was dropped in the back. Interesting. That's a good one because it seems to be repeatable.
So what is that?
That's the force acting on it. And it has caused some problems with one Japanese crew. Actually, some of the stuff fell off of this suspended system I have up there. It came down with a heck of a noise. But I took anything valuable off it there. So